Hi guys, welcome back to my channel is Education Academy. Hope you are doing well. Today I'm going to start a new topic called redox reactions. A redox reaction is a type of reduction and oxidation reaction. Let's see which element undergo reduction, which element undergo oxidation. See that. You know the periodic table. On the left hand side of the periodic table, we will find all the metals, and on the right hand side of the periodic table we can see all the non-metals are present. Now look at that. So these side all metals, and on the right side of the periodic table we have non-metals. So what's the property of the metal? Metal can lose electrons, metal can't gain the electron, or metal can't share the electron. So metal lose electron, non-metal gain electrons, loss of electron or gain of electron. So redox is a simultaneous reaction in which reduction and oxidation takes place simultaneously. Now, loss of electron is called oxidation. Loss of electron is called what we call loss of electron is called oxidation. Oxidation. Gain of electron is called reduction. Reduction. So mostly non-metal get reduced and the metal get oxidized because metal lose electrons and non-metals gain electron. You know the oil rig, oil refineries, oil oil oxidation is loss, reduction is gain. Reduction is gain of electron and oxidation is loss of electron. Oil rig, RIG, oil rig. Reduction is gain of electron. Oxidation is loss of electron. Okay. And I told you just now, it is a simultaneous reaction. Reduction and oxidation takes place simultaneously. What does it mean? It means no oxidation is possible without reduction. In the same way, no reduction is possible without the oxidation. So someone is here, like some metals are here, metal like lithium, sodium, potassium, rubidium, Rb, cesium, francium. And extreme left side of the periodic table, I'm not considering the zero group element, just beneath that one, before that one, we have group 7 of halogens. Like we have fluorine, chlorine, bromine, iodine, astatine. Astatine is radioactive. Anyway, so lithium, sodium, potassium, rubidium, cesium, francium. They have one extra electron in the outer shell. So they can easily give away that electron to 7 group element, to any non-metal. You can ask me a question, sir, why the metal lose electron? Because after losing electron, they will get 8 electron in the outermost shell, which is nothing but octet rule. So they are getting stable. No doubt they are stable, but after losing 1 electron, they become more stable. Okay. So loss of electron is called oxidation. Metals, after losing electron, they get oxidized. Can we say metals get oxidized? Get oxidized. And reduction, gain electron from metals, and non-metal gain electron from metal, so they get reduced, get reduced. So loss of electron and gain of electron. We know that metal get oxidized and non-metal get reduced. Okay. So it is a simultaneous reaction in which reduction and oxidation take place simultaneously. Now, what is meant by the term oxidation number? Let's see what is meant by the term oxidation number. And I have seen in many past paper, you have to work out the oxidation number of even a non-metal or a metal. I will show you how to work out the oxidation number of any element in the periodic table. Okay, write down one question. What is meant by the term oxidation number? Just now we have seen what is meant by the term oxidation number. Okay, let's see what is meant by the term oxidation number. Look at that. I know, guys, I'm rubbing the board and I want like a spotless board or whiteboard that give me a good feeling so that I can write on the board nicely. Okay, look at that. Oxidation number. Oxidation number. There's no positive and negative oxidation number. So look at that. Metal give away one electron and become M plus. Okay, plus one electron. Non-metal X gain one electron and become X minus. Yep, that's for group 1. If suppose I'm going to write a small n here, it means it can be 1 positive charge, 2 positive charge, 3 positive charge. Small minus 1 small n can be any group. So if n equals to 1, the metal should be from group 1. If n equals to 2, metal should be group 2. If n equals to 3, metal should be from group 3. In the same way. Okay. Oxidized, reduced. Okay. Now, it is the charge. What's the oxidation number? It is the charge present on any ions after losing or gaining electron. It is a charge. It is a charge present on any ions, on any ion after losing or gaining electrons. Look at that. Group 1 metals lose 1 electron because they have 1 extra electron. So what is the oxidation number of group 1 metals? Plus 1. Group 2 metals, lithium, sodium, potassium, rubidium, cesium, francium. Plus 1, because they give away 1 electron. Plus 1. Okay. Group 2 metals, they lose 2 electron. Beryllium, magnesium, calcium, strontium, barium, plus 2. They give away 2 electrons, plus 2. Group 3, boron, aluminium, gallium, indium, thallium. Plus 3 because they gives away 3 electrons, plus 3. Okay. Group 4, mostly they are non-metal. They are rather gaining the electron. They would like to share the electron. So I'm just ignoring group 4 for time being. Let's go to group 5. Group 5, nitrogen, non-metal, phosphorus, arsenic, antimony, and bismuth. All are non-metal, but last element of non-metals have a have maximum characteristic property of metals. So mostly it's a solid or more metallic character. Anyway, in group 5, group 6, oxygen, sulfur, selenium, tellurium, polonium, fluorine, chlorine, bromine, iodine, astatine, and zero group element. They are inert. Mostly they are not gaining electron because they have already 8 electrons in the outermost shell except helium. Now group 5 is a non-metal and gain 3 electrons. So minus 3. What is the oxidation state of group 5? Minus 3, because they gain 3 electrons. What is the oxidation state of group 6? Minus 2, because they gain 2 electrons. What is the oxidation state of group 7? Minus 1. Okay. We know now the oxidation state of any element in the periodic table. And one more important point is that the oxidation state of a pure element is always 0. Why? The pure element neither lose the electron nor gain the electron in its own state. In its own state, the oxidation state of any element is 0. We will write down that one soon. So look at that. Is that clear? So oxidation state of metal in the group 1 is +1, +2, +3, -3, -2, -1. We know now. Okay. To write down the means to find out the oxidation state of any element in the periodic table, we have to follow certain rules. We will see the rules today. What are the rules which help to calculate the oxidation state of any elements? Guys, we know that chemical compounds are mostly bonded by ionic bond or bonded by covalent bond. So first, between metal and non-metal, I'm talking about ionic bond. I will teach you how to work out the oxidation number of any element in covalent compounds later on. Let's see in let's see in ionic compound. So if there is a ionic bond, we know that metal give away the electron, so metal get oxidized and non-metal can gain the electron. So metal oxidize, non-metal get reduced. Okay. Okay then. Now look at the oxidizing agent and reducing agent. Which one is called oxidizing agent and which one is called reducing agent? Let's see. Please don't memorize the chemistry, guys. Try to learn the concept. Okay, look at that. Oxidizing agent. I will give you one example. We can understand by looking the example. Let's see. Magnesium react with chlorine gas Cl2. That's gas, guys. Magnesium is a solid. React with chlorine gas Cl2 to form magnesium chloride. I showed you already how to write the formula of magnesium chloride. Please watch my ionic bond videos. Yeah. Anyway, I will show you how to write that. Mg give away how many electron? 2 electron. So it's plus 2 oxidation state. Chlorine gain how many electron? 1 electron. So just put 1 here and put 2 there. Only the number, guys. So the formula, chemical formula of magnesium chloride become MgCl2. Okay. What is the oxidation state of magnesium here? No, plus 2 is 0 because the magnesium in its pure form. What is the oxidation state of chlorine here? 0 in its pure form. And what about the magnesium? What is the oxidation state of magnesium? Plus 2. We know that magnesium is in group 2, lost 2 electron, so plus 2. What is the oxidation state of group 7? Gain 1 electron, minus 1. Look at that. Look at that one. So 0 to become plus 2 and 0 to becomes minus 1. Look at that, minus 1. Okay. So I'm not sure which one get oxidized, which one get reduced. Let's see. So during the oxidation reaction, during this chemical reaction, if the oxidation number increase, it means that element should oxidized. Or if the oxidation number of any element decrease, mean it get reduced. Okay. The element whose oxidation number increase, mean it get oxidized. Okay. Which one is oxidized here? Magnesium. And we know that metal get oxidized. So the element during the redox reaction, if there will be increase in the oxidation state of any element, that element get oxidized, and vice versa. And if there will be a decrease in the oxidation number during the redox reaction, that means that element get reduced. So which one get reduced and which one get oxidized? Let's see. Now, magnesium get reduced and chlorine get oxidized. Look at that. And any element whose oxidation number decreases get reduced. So Mg get oxidized, Mg oxidized, and chlorine get reduced. Now, guys, we have one more small term, that redox, reducing agent and oxidizing agent, OA. What's OA? Oxidizing agent. Oxidizing agent who help in oxidation, supports in oxidation, help in oxidation. RA, reducing agent. Reducing agent, the element which help in reduction. Look at that. Please understand that concept. It's very important for both AS and A2. Even you will get a titration question based on the redox reaction. We have a redox titration. Look at that one. Magnesium only lose electron when there will be any non-metal. Magnesium will not give electron to another metal. Okay, so who is responsible to get the electron from the magnesium? This guy, chlorine. Chlorine is responsible. That guy, chlorine is responsible. Chlorine is the main agent which force the magnesium to lose the electron. So chlorine act as a OA, or you can say the element which get reduced act as a oxidizing agent. Chlorine on the other hand, look at that. Chlorine only gain the electron when we have a metal nearby it. If there will be no metal, if there will be no magnesium, chlorine can't gain the electron. So who is the responsible for the reduction of the chlorine? Magnesium. Magnesium, no doubt, loses the electron for chlorine to safeguard the chlorine, to support the chlorine. What does the chlorine do here? Chlorine get reduced. So magnesium act as a reducing agent. It's just like the one which oxidizes act as a reducing agent, and the one which reduces act as a oxidizing agent. So is that clear, guys? Now, so I will give you one question. Write down the question. Can I rub the board? Okay. What is the chemical formula of sodium oxide? Which element get oxidized and which one get reduced in that? Which one act as a OA and which one act as a RA? Name the type of bond present in sodium oxide. Yeah, if you want, I can add one more question. Why the sodium? I don't want to mean. Okay. There's normally the examiner link a redox reaction with ionic bond or covalent bond. I can ask one question here: why the solid sodium oxide does not conduct electricity? It's a type of ionic bonding question. Anyway, write down the chemical formula of sodium oxide. We will do one by one, guys. What is the chemical formula of sodium oxide? I have already shown the technique how to write the chemical formula of ionic compound. Anyway, I will show you one more time. Sodium oxide. Okay. Sodium oxide. Sodium is in group 1. It gives away 1 electron. Na plus. Oxygen gain 2 electron. O2 minus. Now, look at that. Na give away 1 electron and become Na plus 1 electron. Oxygen gain 2 electron and become O2 minus. So what is the chemical formula? Na plus 1, O2 minus. Use the crisscross technique. So 2 goes here, 2 goes here, and 1 goes there. So the chemical formula is Na2O. That's the answer of my first question. Now, which element get oxidized? We know that metal get oxidized. Anyway, Na plus O2, we will get Na2O. Half oxygen atom. What is the oxidation state of sodium? In its pure form, solid, 0. We know that. That's the gas. What is the oxidation state of oxygen in its pure form? 0. Sodium lose 1 electron, oxygen gain 2 electrons. Okay. I showed you the technique. 0 to become plus 1, 0 to become plus 1, and 0 to become minus 1. The element whose oxidation number increase during the redox reaction, reactant to become product, sodium oxidation number increases, so sodium get oxidized, and oxygen oxidation number decreases, so oxygen get reduced. So who is oxidized here? Na get oxidized. Na plus, Na get oxidized, Na oxidized. And which element get reduced? Oxygen get reduced. Oxygen atom get reduced. Okay, which one act as a oxidizing agent? The element which get reduced act as a oxidizing agent. So the one which one reduce? Oxygen get reduced. Oxygen atom acts as oxidizing agent. Sodium atom get oxidized, so sodium act as a, sorry, my bad. Oxygen act as a oxidizing agent, and sodium get oxidized, so it act as a reducing agent. And you know the type of the bond present between the sodium oxide. Any guesses? Ionic bond. So whenever there is a complete transfer of electron from metals to a non-metal, metal give away the electrons. We know that. Either 1, 2, 3. It depends on the metal belongs to which group. Or the non-metals gains the electron. They can gain 1 electron, 2 electron, and 3 electron. Also depends on which group they belongs to. Okay, so metal always oxidized and non-metal always get reduced. When ionic bond is formed, metal get oxidizes and non-metal get reduces. So guys, I want to wind up my video here. Please like, share, and subscribe my videos. And if you have any question, write down in my comment box. Thanks for watching my video. Welcome back to my channel. Hope you are doing well. Today I'm going to teach redox reactions. I've already started redox reaction. Now that's the second video on the redox reaction. Let's see. First, basically, I want to do some revision here, like what is meant by the term reduction and oxidation. And today we are discussing the rules to find out the oxidation state of any element in the given compound. Look at that. We know that suppose we have ionic compound like NaCl, ionic compound. We have ionic compounds, and covalent compound. Let's see. We have ionic compounds, and covalent compounds. We know that ionic compound is formed between metal and non-metal, whereas covalent compounds are formed between two non-metals. So metal normally give away the electron, metal lose electron and become Na plus 1 electron. So the loss of electron is the oxidation. Loss of electron is oxidation. Okay, and chlorine gain 1 electron, Cl plus 1 electron become Cl minus. Gain of electron is reduction. We know now what is oxidation and what is reduction, like oil rig, guys. But see, in case of covalent compound, how I know which one get oxidized and which one get reduced, like hydrogen chloride, HCl. To figure out which one get oxidized and which one get reduced, we have to use the electronegativity term. We know that the chlorine has the highest electronegativity compared to hydrogen. So it has partial negative charge and this has partial positive charge, meaning this pair of electron shifted towards the chlorine, meaning hydrogen get oxidized and chlorine get reduced. Chlorine get reduced. So if we have a covalent compound, the one which is less electronegative get oxidized, and the one which is highly electronegative gets reduced. Okay, now what is meant by the term oxidation state? Any guesses? Okay, look at that. Oxidation state or oxidation number, both are fine. Look at that. Oxidation state or oxidation number. Oxidation state or oxidation number. Okay. See, whenever there is a formation of the bond, some element gain the electron or some element lose the electron. When any element gain or lose electron, it got a formal charge. The formal charge present on any element is the oxidation state of that element. So that's the formal charge. The formal charge present on any ion after gaining or losing electrons. Now, so we know now what is meant by the term oxidation state. So we have some rules to figure out the oxidation state of any element in the given compound. Let's go through one by one. Okay. The group 1 metal give away one electron. Group 1 metals, like for example, we have lithium, sodium, potassium, rubidium, cesium, francium. How many electrons they lose? One electron. So they have plus one charge. That's the oxidation state of a group 1 metals. The OS, the oxidation state of group 1 metals, has group 1 metals have plus 1 oxidation state. The OS of group 2, the oxidation state, the OS of group 2, alkaline earth metal. First one is alkaline metals, second one is alkaline earth metal. Group 2, group 2nd. Metals have plus 2 because they give away 2 electrons. So group 2, group 2, beryllium, magnesium, calcium, strontium, barium. Now group 3, oxidation state of the group 3. The oxidation state of group three metals as they give away 3 electrons have plus 3. The oxidation state of a group 1 metals have plus 1. The oxidation state of group 2 metals have plus 2 plus 3. Now group 4, mostly they are forming a covalent compound, so rather they are sharing. So I'm trying to ignore here. Now group 5, group 3 like a boron, group 3 boron, aluminium, gallium, indium, thallium. Group 5, the oxidation state of group 5 elements, they are not metals, they are elements. Element have minus 3 because they gain 3 electrons. I'm talking about in general, guys. Nitrogen in various compounds show variable oxidation state. We will discuss later on. But in general, group 5 elements, they have, what are the group 5 elements? Like nitrogen, phosphorus, arsenic, antimony, bismuth. They have 5 valence electron, so they gain 3 electron when they form ionic bond. I'm talking in general, guys. But when you look at the nitrogen and its compound, nitrogen and phosphorus, they are showing variable oxidation state. Especially the p block elements are showing variable oxidation state. Okay, I'm talking about the I'm talking about the ionic bonding. The OS of the oxidation state of group 5, group 6 elements have minus 2 oxidation state. Oxygen, mostly the oxygen showing a minus 2 oxidation state, except in OF2. I will tell you the reason behind it. And hydrogen peroxide and its peroxide. The oxidation state of group 7 elements have minus 1, like fluorine, bromine, chlorine, bromine, iodine, astatine. They gain 1 electron. Okay, please quickly copy on that one. Can I rub this board, guys? Okay, now I have some more rules to work out the oxidation state of any element in its given compound. The oxidation state of any pure element is 0 because it is in its pure form. The oxidation state of any pure element or any pure element is 0, guys, because it is not making any bond. That's in its pure form and its original state. The oxidation state of a compound as a whole is also 0. We didn't get it, sir. Okay, like for example, I have HNO3, like the whole compound is 0. I'm not talking about the individual compound. I'm not talking about the individual element. The whole of the compound is 0. There's no formal charge on nitric acid, so it's 0. Now, oxidation state of some gases. Look at the oxidation state of the gases, mean diatomic gases. the oxidation state of diatomic gases. For example, like we have hydrogen gas H2, comma nitrogen gas N2, comma oxygen gas, chlorine gas, bromine gas, fluorine gas. 1, 2, 3, 4, 5, 6. Yes. It's also zero. Why? I will tell you. It's also zero. Why? Because there is no difference in electronegativity. Look at that. Hydrogen combines with hydrogen. Is there any difference in electronegativity? No. 0, 0. No difference in electronegativity. Look at the nitrogen. Nitrogen, when it's combined with one more nitrogen, there will be no difference in electronegativity. So, oxidation state of any nitrogen in its compound is zero because there is no pulling of electron. Electron is shared by these two nitrogen equally. So 0, 0. Okay. Chlorine, no electronegativity difference, so there will be no pulling of electron towards one chlorine. That's why oxidation state is zero. Now, oxidation state of oxygen is always -2, but in certain compound it is showing different oxidation state. Like please write down this as a rule. The OS oxidation state of oxygen is always -2, but in OF2, except in OF2 and H2O2, hydrogen peroxide, but except in OF2 and hydrogen peroxide, oxygen is showing different oxidation state because of the peroxy linkage here, and fluorine is highly electronegative. That's why oxygen is not showing -2 oxidation state. Okay, one or two last one or two rules, guys. Okay, look at that. One or two. Let's see the hydrogen. Hydrogen, when combined with metal, it's always showing -1 oxidation state. So we have metal hydride. We have hydrogen with metal hydrides, HYDRIDES. So hydrogen is always showing -1, and hydrogen, when it combines with non-metal, hydrogen is showing +1 oxidation state. Hydrogen, metal hydrides, hydrogen has +1, hydrogen has -1 oxidation state in metal hydride, -1 oxidation state in metal, in non-metal, with non-metals like HCl, in nitric acid, always hydrogen has +1 oxidation state. Okay, we have seen the various rules to figure out the oxidation state of any element in the given compound. Let's do one example. Okay, I want to just quickly rub this board. All the rules, you don't need to memorize it. I want to give you have seen just now, you have seen all the rules. Let's see. You don't need to memorize all the rules. It will come when we do various examples. I'm giving you different examples, and I'm going to apply all these rules in the various examples. Let's see. So write down the question. Find the oxidation state of some underlying elements. For example, I have Mn in KMnO4, potassium permanganate, and chromium. That's the alanine. You will get these type of question in your exam. And chromium in K2 potassium dichromate, K2Cr2O7. I will show you, I will give you an easy formula, like a mathematical formula. Look at that. So we have to figure out the oxidation state of K manganese in KMnO4. Yeah, I don't know manganese, but I told you the overall charge of this compound is 0, so the oxidation state of this compound is 0. Okay, potassium come from group 1, so group 1 has +1 oxidation state. Manganese, I don't know what's the oxidation state of manganese, Bx, plus oxygen always show -2. How many oxygen do I have? 4, equals to 0. 1 plus x minus 8 equals to 0. X minus 7 equals to 0. X equals to 7. Okay, let's do the chromium in potassium dichromate. So apply the same formula. It's easy to figure out. So K2Cr2O7. K2, even you can get sodium dichromate, same thing, sodium with potassium. K2Cr2O7. Okay, equals to 0, and K 1 times 2 plus 1 times 2, potassium is in group 1, so give away 1 electron, plus 2x minus 14. I jumped my gun, so plus minus 2 times 7 equals to 0. 2 plus 2x minus 14 equals to 0. 2x minus 12 equals to 0. X equals to 12 over 2 equals to plus 6. But I can't use this method to work out the oxidation state of some elements. For example, I will give you I will give you this example. Let's try as a homework. For example, I have Na2S4O6, sodium tetrathionate. Just figure out this one. It means this is not the 100% perfect way to figure out the oxidation state of any element in the given compound. So what's the best way to figure out the oxidation state? The best way is that you have to draw the structure, but that's the tedious and laborious process to draw the structure. But anyway, if you learn the structure, you will definitely figure out the oxidation state of any element in the given compound. Let's do that way also. For example, one more. Okay. Find the oxidation state of sulfur in sulfuric acid. Let's do by the structural method. So we have one method through the formula and another method through the structure. Let's see the structural method. Find the oxidation state of sulfur in sulfuric acid. I will show you guys by two ways, one through the formula and one through the structure. No, look at that. But you have to know the structure of the sulfuric acid. Look at that one. S double bond O. Sulfuric acid H2SO4. So I have O and H. I have O and H, and we have four oxygen and H2SO4 double bond oxygen, double bond oxygen, O hydrogen, O hydrogen. Oxygen, each oxygen one bond, so -1 plus 1, -1 plus 1. Look at one more. This oxygen and sulfur. Oxygen is highly electronegative. -1 plus 1, -1 plus 1. Here also you have, look at that one, -1 plus 1. Each oxygen make 2 bonds. So this is +1, this is -1 with the hydrogen. But with sulfur, it show negative charge. So here also -1 on oxygen and +1 on sulfur. Look at that. 1, 2, 3, 4, 5, 6. So oxidation state of sulfur in sulfuric acid, it's +6. I will quickly show through the formula how can we figure out with the help of the formula. We know the hydrogen is +1. +1, how many hydrogen? Times by 2. I don't know. Sulfur X plus oxygen is always -2. How many oxygen? 4 equals to 0 because there is no overall charge. Now 2 plus X minus 8 equals to 0. X minus 6 equals to 0. X equals to 6. By both the ways, you can get the oxidation state of sulfur as +6. But I can't use this method for some compound, like for example this one. So I want to stop my video here, guys. And if you have any question related to the oxidation reaction, or if you wish to figure out the oxidation state of any compound, please write down that question in my comment box. I will get back to you. Thanks for watching. Hi guys, welcome back to my channel. Hope you are doing well. Today I'm going to teach redox reactions. I've already started redox reactions, and we have seen how to calculate the oxidation state of each element in the compound. So I want to do the various examples, and we can work out the oxidation state of each element by two methods. One is the formula method, by using formula, and another method is just by drawing its structure. Drawing its structure is the 100% secure way to figure out the oxidation state of any element in the given compound. But for that, we have to either memorize or we should know the structure of each compound. Let's use both formula and the drawing. So let's do oxidation state of S in SO2, SO3, H2SO4, S8, and we have sulfur dioxide, sulfur trioxide, sulfuric acid, S8. Let's do H2SO3 and S8. Sulfur dioxide, S double bond O, double bond O. Among sulfur and oxygen, which one is highly electronegative? We know oxygen is highly electronegative, so -1, -1, +1, +1, because 2 minus, -1, -1, +1, +1. Oxidation state of sulfur, it's +4. SO3, double bond O, double bond O, double bond O. So -1, -1, -1, -1, -1, -1, +2, +2, +2. 6. Sulfuric acid, S double bond O, double bond O, OH, OH. -1, -1, -1, -1, oxygen -1, -1, -1, +1, +1, -1, -1, -1, +1, +1. So here +2, here +2, these two +2, these two +2, +1, +1, also 6. Let's do SO3. S double O hydrogen, O hydrogen, double bond O. -1, +1, -1, +1, +2. From that +1, from this side +2, -1, -1, -1, +1, -1. So from that side +1, +4, 1, 2, 3, 4, +4 oxidation state. Okay, S8, S8, sulfur here form a crown-like structure. So there will be no difference in the electronegativity of the sulfur. So S in S8 equals to 0 in its pure form. Here 0, 0, because there is no difference in electronegativity. 0, 0, 0, 0, 0, everywhere is 0. Can we use the formula to figure out the oxidation state of sulfur in all these compounds? Yes, we can use the formula. I will try sulfur, this sulfurous acid. This is sulfuric. I want to try that one. Okay. Can I rub the board? Look at that one. Sulfurous acid. Now, I want to work out the oxidation state of sulfur in sulfurous acid. This is sulfuric, H2SO4 +6. Let's see. Hydrogen +1, we have 2 hydrogen. Sulfur, we don't know X. Plus -2, oxygen is always -2, except when oxygen combine with fluorine or peroxides. Times by 3 equals to 0, because overall oxidation state is 0. So 2 plus X -6 equals to 0, X -4 equals to 0, X equals to 4. So we have some books, it is given as this is sulfuric acid but +6, this is also sulfuric acid but +4. Oxidation state of sulfur in this sulfuric acid is +4, so +4 sulfuric acid plus 6 sulfuric acid. Now we will do oxidation state of chlorine in different compounds of the chlorine or phosphorus. Let's do the phosphorus first. Oxidation state of phosphorus in its various compound. A PH3, which is phosphine. B phosphoric acid. C H3PO3. D H3PO2, and last one EP4. Let's see. Phosphorus also showing variable oxidation state. Let's see. Phosphorus, hydrogen, hydrogen, hydrogen. So hydrogen is less electronegative, negative +1, +1, +1, -3. So -3 oxidation state. Now H3PO4, PO hydrogen, O hydrogen, O hydrogen, double bond. Phosphorus can form 5 bond, 1, 2, 3, 4, 5. Okay. Phosphorus is a less electronegative compared to oxygen. So -1, -1, -2, -1 +1, +1 from the phosphorus, -1 from the oxygen, -1 +1, -1 from the phosphorus, -1, -1, +1, 1, 2, 3. So +1 from here, +1, +1, +2. P equals to 5. 1 +1 +1 +1 +2. Okay, I will do from the formula, guys. H3PO3, PO hydrogen, double bond, hydrogen, OH, O and H, and H. Which one is highly electronegative among oxygen and phosphorus? Oxygen. So -2, 1, 2, so +2, -1 +1, -1 +1, +1, -1, -1, +1, -1, -1, +1. Here, hydrogen is less electronegative compared to phosphorus. So phosphorus is -1 +1. So total 2, 3, 4, -1. So +3. Look at that. 2, 1, 2, -1. So +3. Phosphorus also showing variable oxidation state. P block elements always show variable oxidation state. Now phosphorus in P H3PO2, P double bond O, hydrogen, hydrogen, high O and H. -2, +2, +1, -1, +1, -1, +1, -1, -1, +1, +2, -2, +1. So +3, -2. Look, +2, -2, -1, -1 cancel, +1. P equals to 1. So it's showing -3, +5, +3, +1. Variable oxidation state. And phosphorus is 0. Phosphorus like a tetrahedral molecule. Phosphorus, look at that. The electronegativity difference 0, 0. So phosphorus equals to 0 here. Now we will see some NO2. We will see the oxidation state of nitrogen, NO2, carbon, CO2, chlorine in carbon tetrachloride. You want to do with by using formula, any one of the example by using formula. Okay, let's do this one by using formula H3PO2 equals to 0, hydrogen plus 1 times by 3, phosphorus I don't know, so X plus minus 2 equals to 0, 3 plus X minus 2 equals to 0, X equals to 1. Oxidation state of nitrogen in NO2, NO3, HNO3, NO2, double bond O, double bond O. I know nitrogen cannot form 4 bond, but for time being, just think it form because it has a dative bond. Just ignore the point. And B nitrogen, double bond O. It can form dative, so let's do the NO3 because of the dative bond. I don't want to take that one, sorry, just because nitrogen can't make many bonds. So we will do this we will do this structure by using formula. So nitrogen minus 1 plus 2 minus 1 plus 2 minus 1. So N equals to plus 4. Okay. N hydrogen, a double bond O, HN 1, 2, 3. Plus 1, minus 1, minus 1, 1, 2, 3, 3 hydrogen. Minus 1, plus 1, minus 1, minus 1, minus 1, minus 1, plus 2. Okay, I don't think because of the dative bond. Let's use the chemical let's use the formula to figure out, not the chemical formula to figure out oxidation state of nitrogen in HNO3. X, hydrogen is plus 1, plus X minus 2 times 3 equals to 0. 1 plus X minus 6 equals to 0. X equals to plus 5. Here also equals to 0. Because of the dative, nitrogen and oxygen sometimes form a dative, 100% forming a dative bond. That's why I can't draw the structure. The structure will not help you to figure out the oxidation state of nitrogen, but we can use the formula. Nitrogen X plus minus 6 equals to 0, X equals to plus 6. Okay. Carbon in CO2, C double bond O, minus 1 plus 2, minus 1 plus 2. So C, oxidation state of carbon in CO2 is plus 4. In carbon tetrachloride, Cl. Now chlorine minus 1. So this is plus 4. Carbon equals to plus 4. Okay. Now we have some specific compounds which we cannot apply this formula to figure out the oxidation state of particular element. Let's see that. specific examples. Now, sodium tetrathionate. First we will do hydrogen peroxide, H2O2. Let's see, H2O2, hydrogen peroxide. H2O2 plus 2 plus hydrogen and oxygen, suppose we don't know, 2x equals to 0. So 2 plus 2x equals to 0. 2x equals to minus 2. X equals to minus 2 over 2. So minus 1. Let's draw the structure of hydrogen peroxide. It's just like an open book shape. Plus 1, minus 1. So each oxygen has minus 1 oxidation state. Minus 1, plus 1. One more example. Sodium tetrathionate, Na2S4O6. Let's check the oxidation state of sulfur by using formula. So Na plus 1 times by 2 plus 4x minus 12 equals to 0. 2 plus 4x minus 12 equals to 0. 4x minus 10 equals to 0. So x equals to 10 over 4 or 2 or 5 over 2, which is 2.5. So we can't work out by using this formula. Let's draw the structure and see what is the oxidation state of each sulfur in sodium tetrathionate. Look at that one. I want to draw its structure and you can clearly see what is the oxidation state of each sulfur in that structure. So we have sulfur, double bond O, Na, sulfur, double bond O, O, Na, Na, sodium tetrathionate. Oxygen minus 1, sodium plus 1. Minus 2, so plus 2 here. Minus 2, each oxygen minus 2, so plus 2 here. Minus 1, plus 1. Okay. Here sulfur, 0. Sulfur, 0. Sulfur, 0. So minus 2, this is plus 2, minus 1, plus 1, minus 1, plus 1. So each sulfur has plus 5 oxidation state. This sulfur has plus 5, this sulfur has 0, this sulfur has 0, this sulfur has plus 5 oxidation state. This is actually the average oxidation state of all the sulfur, which is wrong. We can't use the formula to figure out the oxidation state of sulfur in sodium tetrathionate. One more example. Sodium tetrathionate. Let's do one more example. Okay. find the oxidation state of chromium in CrO5 and bromine in Br3O8. Let's use the formula first. Chromium X plus minus 2 times by 5. Minus 2 times by 5 equals to 0. So X minus 10 equals to 0. X equals to 0. I don't think so. Look at that. Chromium has this type of structure. Chromium in CrO5, that's the structure. This is the structure, like a butterfly structure. Oh, now look at that. This is minus 1, minus 1. So this is plus 2. Plus 1, minus 1. Plus 1, minus 1, plus 1. Minus 1, plus 1. Minus 1, plus 1. 2, 2, 3, 4, 5, 6. So chromium oxidation state is plus 6. This oxygen minus 2, this oxygen minus 1, minus 1, minus 1, minus 1. So chromium is having plus 6 oxidation state. So when you use the formula, we can't get oxidation state of chromium is showing as plus 5, which is wrong. So sometime we have to just practice the drawing of the compound or just memorize the structure of the compound. I want to use the formula. So 3x minus 3x plus minus 2 times 8 equals to 0. 3x minus 16 equals to 0. X equals to minus x equals to 16 over 3, which is more, which is 3 5s are kind of more than 5. Let's draw the structure and try to figure out what is the oxidation state of bromine in Br3O8. Please copy down that one. Bromine in Br3O8. Got that. Bromine, 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 double bond O, 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 double bond O. So this is minus 2, this is minus 2, this is minus 2, minus 1 2, minus 2, minus 2. So here plus 6. Agree. Plus 1, plus 1, plus 1, plus 1, plus 1, plus 1. Bromine, bromine, 0. This bromine, 0. This bromine, 0, because there is no difference in electronegativity. Minus 2, so plus 2. Minus 2, plus 2. This bromine has oxidation state plus 4. Here minus 2, minus 2, minus 2. So my plus 2, plus 2, plus 2. So this bromine, what's the oxidation state? Plus 6. For this bromine, what's the oxidation state? Plus 4. For this bromine, what is the oxidation state? Plus 6, like that. So sometimes we can't use the formula. We have to use the structure of the compound. But mostly we can use the formula. The problem is that some molecule, they have a peroxy linkage. Then we can't figure out the oxidation state of each compound in a peroxide, in a superoxide, or this type of structure. So I want to wind up my video here. If you have any question, please write down in the comment box below. I will get back to you. Thanks for watching my video. Take care. Bye bye. How are you? Hope you are doing well. Today we are learning how to balance half equation by ion electron method. Before that, let's continue my topic of calculating oxidation state of any element in the given compound by drawing structure. I want to add one more compound, that is ferrous acid, H2 H2SO5. If you use the formula, like for example, hydrogen 1 times 2 plus x plus minus 2 times 5 equals to 0. 2 plus x minus 10 equals to 0. X minus 8 equals to 0. X equals to 6. X equals to 8, which is not possible. Sulfur has a maximum oxidation state of +6. Oxidation state of any element never exceed to its group number. So sulfur has +6 oxidation state. Why we didn't get the answer by this method? Because of this peroxy linkage. Let's draw the structure. Hydrogen O, sulfur, double bond O, double bond O. How many hydrogen? 1, 2, 3, 4, 5, and a hydrogen. 5 hydrogen, 5 oxygen, 2 hydrogen, 1, 2, and sulfur. So minus 1 plus 1. Each oxygen minus 2. This is minus 1, minus 1. So here sulfur plus 2. Oxygen and this sulfur. So oxygen minus 1, this sulfur is plus 1. Here from 2 bond, so this oxygen has minus 2 oxidation state and that sulfur has plus 2 oxidation state. And from that side, look at that. Oxygen has minus 1 and this sulfur has plus 1. Minus 1 plus 1, minus 1 plus 1, minus 2 plus 2, minus 2 plus 2. Oxygen, 0. This oxygen, no difference in electronegativity, 0. So this oxygen is minus 1, this hydrogen is plus 1. Look, my plus 1 plus 1, 2, plus 2 plus 2, 4. So oxidation state of sulfur in ferrous acid is +6, which is quite obvious. So sulfur shows +6 oxidation state. Sulfur shows variable oxidation state, but to the maximum extent it shows 6 oxidation state, +6 oxidation state. If you follow the formula, we got a wrong answer because of this peroxy linkage. Now we do some question of ions. Sometimes they will ask to find out the oxidation state of any element in the given ions. So we will do the ions. Okay. Oxidation state of any element in the given ions, guys. Find the oxidation state of, find the oxidation state of, find the oxidation state of, find the oxidation state of phosphorus in PO4 3-. Find the OS of nitrogen in NO3-. Find Find the OS of oxidation state of chlorine in ClO4 minus perchlorate ion A, B and C, H3PO4 minus, now NO3 1 minus, nitrogen X, I don't know, plus oxygen each time 2 times 3 equals to minus 1 here. The overall charge is minus 1, so minus 1 here. X plus minus 6 equals to minus 1. X minus 6 equals to minus 1. X minus 5 equals to 0. So X equals to plus 5. And the same way, ClO4 minus, ClO4 1 minus, chlorine X plus minus 2 times 8 equals to minus 1. X minus 8 equals to minus 1. X minus 7 equals to 0. X equals to 7. Can I rub the board? Phosphorus in PO3 minus. Let's see phosphorus in PO3 minus. Now, phosphorus PO4 3 minus, overall charge is 3 minus, X minus plus minus 2 times 8 equals to minus 3. X minus 2 times 4, my bad, 2 times 4, so minus 8 equals to minus 3. X minus 5 equals to 0. X equals to plus 5. Yeah. Now we have a displacement reaction. Displacement reactions are also a redox reaction. Let's work out the oxidation state of any element in the given equation through displacement reaction. Displacement reactions. We know halogens. So in halogens, which are 7 group element, which one is the first element? Fluorine is the first element of halogen. Fluorine is highly reactive because of the small size. Can fluorine displace other halogen from its aqueous solution? Let's see. Can fluorine displace other halogen from its aqueous solution? Now, fluorine, look at that. Halogens, fluorine, chlorine, bromine, iodine. Fluorine displaces chlorine from its aqueous solution. Fluorine displaces bromine from its aqueous solution. Fluorine also displaces iodine from its aqueous solution. This is called group displacement reactions or group displacement law. Group displacement reactions. Fluorine is highly electronegative or highly reactive, so fluorine can displace chlorine, bromine, iodine. F2 plus KCl give aqueous, give KF, balance 2 plus Cl2 gas come out. What's the oxidation state? 0. Pure element has no oxidation state. Plus 1 minus 1, plus 1 minus 1, 0. Look at that. So 0 to become minus 1, minus 1 to become 0. Can you notice that? there will be no change in the oxidation state of the K. So if there will be no change in the oxidation state of any element, that element is called spectator ion. It's just watching the reaction, no change. Look at that. 0 to -1. Guys, increase or decrease? 0 to -1, going back. So 0 to -1. 0 to +1. During the course of the displacement reaction or during the course of the reaction, if the oxidation state decreases 0 to -1, meaning that element get reduced. So fluorine F2 is reduced. What about the chlorine? Chlorine, look at the oxidation state, -1 to 0. Oxidation state increases, meaning it get oxidized. Cl2 is oxidized. Now, one more. Can chlorine displaces bromine and iodine? Yes, chlorine can displaces bromine and chlorine can displaces iodine. Yes. I want to give you one example. So K, instead of KCl you can use KBr. Cl2 plus KBr plus bromide aqueous solution. We'll get KCl, 2 KCl, balance it, 2 KCl. Did I balance here? Yeah, balance here. So 2 here, yeah, 2 KCl, 2 KBr plus C, 2 KCl plus Br2. It displaces bromine. Okay, let's see which one get oxidized and which one get reduced. 0 plus 1, just ignore 2. We are using 2 to balance the equation, not to figure out its oxidation state. -1 plus 1 -1 0. Look at that. Chlorine 0 to -1 decreases, reduced. -1 to 0 increase, oxidized. So chlorine get reduced, gain electron, because chlorine becomes 0 to -1, gain electron, and bromine get oxidized, lost 1 electron. Can bromine displace iodine? Yes. Let's see one example. And iodine can't displace any of the halogen in the periodic table. Okay. Now, Br, bromine gas, Br2 plus Ki, 2Ki becomes KBr, 2KBr plus I2 gas. Okay, what's the oxidation state of bromine? 0 plus 1 -1 plus 1 -1 0. Oxidation state of a pure element is 0. Now look at the change. Bromine 0 to becomes -1, -1 to becomes 0. 0 to -1 decrease, so reduced. -1 to 0 increase, so oxidized. They will ask in the examination, they will give you this question and they will ask you which element get oxidized, which element get reduced. The element which get oxidized act as a reducing agent. So if F2 get oxidized, what's the function of F2? Acts as a OA, oxidizing agent. If chlorine get oxidized, act as a reducing agent, well-known reducing agent. So without calculating or without using the formula, without writing the equation, can we quickly figure out which element get oxidized and which element get reduced in this equation? Yes. See, the top one always reduces. So fluorine always reduces in case of chlorine, bromine and iodine. And if we have chlorine with all these remaining elements, so chlorine get reduces, the top one get always reduces. So this get reduced. Chlorine when react with bromine or when react with iodine get reduces. So top one always reduces. And when bromine react with iodine, bromine get reduces, they get reduced, and iodine always oxidizes. Iodine never reduces. So this is called group displacement reactions or group displacement law. Okay. Look at the question. Predict the elements which have oxidized and reduced in the given equation. So chlorine, when react with the water molecule, what we are getting? We're getting HCl plus HClO or HOCl, same thing, with a bleach. Now we have to see which element get oxidized and which element get reduced. Chlorine, what's the oxidation state of chlorine? 0, hydrogen plus 1, oxygen minus 2. I'm talking about each individual element. I know we have 2 hydrogen times by 2. Plus 1, minus 1. Here, I don't know chlorine. Chlorine never be minus 1 if it is combined with oxygen. Why? Because oxygen is highly electronegative element. So it takes the shape pair of electron. Most of the students, they are putting minus 1, minus 2 and plus 1. That's wrong. So the total is 0. I want to show you here HClO, which is equals to 0. Hydrogen 1, I don't know X chlorine, and oxygen is minus 2 equals to 0. X minus 1 equals to 0. So X equals to plus 1. So hydrogen is plus 1. You know that. Plus 1 minus 2. So overall 0. Let's see which element has been oxidized and which element has been reduced. So 0, 0, 2, minus 1. Yes. And 0, 2, plus 1. Is there any change in the oxidation state of hydrogen? Nope. And what about the oxygen? Nope. So chlorine, here chlorine 0, 2, minus 1, meaning decrease in the oxidation state, gets reduced. Chlorine 0, 2, plus 1 get oxidized. So the same element, chlorine, here get oxidized and reduced. What type of this reaction is that? Most of my students, they said redox reaction. I do agree. This is a redox reaction, but this is a unique or a particular redox reaction. A redox reaction in which the same element get oxidized and reduced. What we call such type of reaction? Any idea? These reactions are called disproportionation reaction. What is a disproportionation reaction? Very important, guys. For AQA, for OCR, for Edexcel, definitely you will get this type of question. Disproportionation reaction. A reaction in which same element get oxidized and reduced is called disproportionation reaction. I will give you some example of disproportionation reaction. What is a disproportionation reaction? It is a type of the redox reaction in which the same element get oxidized and reduced. One more example of disproportionation reaction. Okay, I want to rub that one. Sodium hydroxide when react with chlorine, when chlorine gases passes through the sodium hydroxide, we have two conditions. You can take the cold and dilute sodium hydroxide and hot and concentrated sodium hydroxide, Cl2 plus NaOH, cold and diluted, you are getting NaCl plus NaClO plus H2O. Check whether this is a disproportionation reaction or not. Let's see. Chlorine 0, sodium plus 1, hydrogen minus, oxygen minus 2, hydrogen plus 1, Na plus 1 always, minus 1, Na plus 1, chlorine plus 1, minus 2, hydrogen plus 1, oxygen minus 2. Is there any change in the oxidation state of sodium? No change. Plus 1, plus 1, plus 1, spectator ion. Is there any change in the oxidation state of oxygen? Minus 2, minus 2, minus 2, no change. What about the hydrogen? Is there any change? Plus 1, plus 1, no change. So look at the chlorine. Chlorine here, 0, 0 to become minus 1 and 0 to become plus 1. So this is an example of redox reaction. I will give you one more last redox reaction, and in which the same element get oxidized and reduced. So this is an example of disproportionation reaction. I will give you one more example of disproportionation reaction. Same, when chlorine react with conc and hot sodium hydroxide, what happens? The products are completely different. Hot, this is cold and dilute. We will see the hot and conc NaOH. Hot and conc NaOH. Hot and concentrated NaOH. Sodium hydroxide. Now, chlorine react with sodium hydroxide. The condition here is hot and conc. Chlorine plus NaOH gives NaCl here, sodium chlorate NaClO3 plus H2O. How many sodium? You try to balance it, guys. So 5 NaCl, 6 chlorine. So 5 here, 1 balance. 6 sodium, 5 plus 1 balance. How many oxygen? 6 oxygen, 3 here, 3 here. How many hydrogen? 6. Balance. What's the oxidation state of chlorine here? 0 because of the pure element. 0, 0. Sodium plus 1, hydrogen, oxygen minus 2, hydrogen plus 1. Plus 1, minus 1. Plus 1, plus 5, minus 2. I'm talking about each one. When you work out the oxidation state of chlorine here by using the formula, you will get plus 5. Hydrogen plus 1, oxygen minus 2. Just ignore 3. So look at that. What happened? Chlorine 0 to become -1, and chlorine 0 to become +5. What about the oxidation state of sodium? +1, +1, +1, no change. So sodium is the spectator ions here. -2, -2, -2. Hydrogen +1, +1, no change. This is also an example of a disproportionation reaction. I want to stop here. If you have any question on the disproportionation reaction or the displacement reaction, please write down in my comment box. And whenever you are free, guys, please watch my videos. Thank you so much. Hope you are doing well. Today we are learning balancing the half equation, which is the important point of, which is a very important question for all the A-level examination. You will definitely get one question based on balancing half equation by ion electron method, by using both ions and electron. Mostly we use electron to balance the equation. Look at that. First, I will teach you the rules to balance the half equation. Look at that equation. MnO4 minus becomes Mn2 plus. One more equation, that's complete equation. So we divide that equation into two parts. Fe2 plus becomes Fe3 plus. Later I will write the one complete equation and I will show you how to split them based on the oxidation and reduction. First, we will follow some rules to balance the half equation. Look at that. It is one complete equation, but I split into two equations based on the compounds which, or the elements which get oxidized, or the elements which get reduced. So these two are separate equations. We are writing these equations separately. So let's focus on MnO4 minus. It becomes Mn2 plus. See that? So look at that. How to balance this one? Oxygen and overall charge is -1. Always balance elements by just inspection. Now, the second part is balance oxygen. So arbitrarily, I divided this as my right side and this is my left hand side. Okay. On the left hand side, I have excess oxygen. So how you would like to balance the oxygen? Oxygen atoms are balanced by using water molecule. Balance oxygen atoms by adding water molecule, by adding H2O. On which side? Where we have no oxygen or less oxygen, by adding H2O. On the which side we have no oxygen? On the right hand side. Add water molecule on the right hand side. MnO4 minus becomes Mn2 plus. How many oxygen atoms are more on the left side? 4. Add 4 water molecule, 4 H2O. When you add 4 water molecule on the right hand side, hydrogen atom get exceeded, or we have hydrogen atoms on the right side. How can we balance hydrogen atoms? Balance hydrogen atoms by adding H plus ion. You know, we can balance this equation in two conditions, in acidic medium and in alkaline medium. So first we are doing acidic media or acidic medium. balancing the half equation by using ion electron method in acidic medium. Okay, that's why we are adding H plus ion. How many hydrogen are extra on the right side? 8. Add 8H plus on the left side. There is no such right hand side and left hand side. For my convenience or to explain, I just arbitrarily take it as that's the right side and that's the left side. So add 8H plus on the right hand side, on the left side, plus MnO4 minus becomes Mn2 plus 4H2O. Okay. Now, the final part is balance the charges. Work out the charges on both the side. 8 positive guys, take away 1 negative. How many positives are here? 7 positive. So on this side I have 7 positive charges, and on the right side 2 positive charge. So out of 7 positive charge, it gives away 2 positive charge on the product side. So how many positive charges are left on the left side? 5 positive charge. One more time. Look at that. 8 positive charge, take away 1 negative charge. How many positive charges are there on the left side? 7 positive charges. Out of 7 positive charges, on the reactant side, the reactants gives 2 positive charge on the product side. So take away 2 positive charge. That's 5 positive charges on the left side. So how can we balance positive charges? By using electron. So add 5 electron. Which side we have more positive charge? Left side. So add electron on the left side where we have excess positive charges. Balance positive charges by adding electrons the side where we have more positive side charge, where we have more positive charge. How many positive charges are extra here? 5. So add 5 electrons. 5 electrons plus 8H plus MnO4 minus gives Mn2 plus 4H2O. Now check whether this reaction is completely balanced or not. Look, how many Mn? 1 Mn, 1 Mn on both the sides. Perfectly balanced. How many oxygen atom? 4 oxygen atom. 4 times 1, 4 oxygen atom. 8 hydrogen atoms. 4 times 2, 8 hydrogen atoms. Now the charges. 8 positive, 5 negative, electron has a negative charge. 5 plus 1, 6 negative charge. 8 positive, look at that, 8 positive charge on this side, 8 positive charge minus 6 negative charge. How many left? 2 positive. So 2 positive left on the product side. So everything is balanced here. Now, what's the another half equation? Fe2 plus becomes Fe3 plus. Now Fe2 plus becomes Fe3 plus. These two are one equation. Look, MnO4 minus gains the electron here. So MnO4 minus get reduced here. That's why MnO4 minus acts as a well-known oxidizing agent. It oxidizes Fe2 plus to Fe3 plus. Oxidizes meaning it takes the electron from Fe to Fe3 plus. One more thing, I've seen in many textbooks or most of the teachers, first they will write the complete equation, and what they will do, they will work out the elements which undergo oxidize and the elements which undergo reduce, and they will keep them separate in two equations. I will teach you this later on, but I want to start the half equation first, and what are the rules to balance the half equation. Then we will crack the questions based on the complete equation. So the another part of this equation is Fe2 plus becomes Fe3 plus, meaning MnO4 minus oxidizes Fe2 plus to Fe3 plus. Is there any oxygen? No. So we don't need to balance the oxygen atom. Don't worry about the oxygen atom. So don't need to balance hydrogen. How many Fe? 2 Fe. How many Fe? Sorry. How many Fe? 1 Fe ion, 1 Fe ion. Okay. Now we have to balance the charges. Look at the one. 2 positive, 3 positive. Which side positive charges are excess? This end. So I want to add 1 electron here to balance this equation. Okay, yeah, this equation is balanced. Yes. How many Fe? 1 Fe on the reactant side. How many Fe on the product side? 1 Fe on the product side. 2 positive, 3 positive, 1 negative. Balance. After that, you have to add both the equations. Suppose this is my one equation or A equation or anything. I don't mind. Suppose this is my one equation which undergo reduction. So this is my oxidation equation. You can give any notation, any numbering, or any letter, whatever you feel convenient. So this is my 2-1. When we balance the overall equation, you have to cancel the electrons. That's my first, guys. That's my first. When you balance these two overall equation, you have to cancel the electron in both the equation. How I cancel the electrons? First of all, check the electrons should be on the opposite side of the reaction. This is on the left side, this is on the right side. So if the electrons are both are on the same side, it means you have done some mistake. So check the electron should be on the opposite ends. How can we balance the electron? This equation has 5 electrons and that equation has 1 electron. So the easy way, I have to time this equation 2 by 5. I want to time this by 5. So what you will get? You will get 5 Fe2 plus 5 Fe3 plus 5 electron. Agree? Okay. Just I want to rub that one. Now look at that one. So 5, I want to rewrite these two. 5 electron plus 8H plus MnO4 minus becomes Mn2 plus 4H2O. That's my one equation. Another equation, 5 Fe2 plus becomes 5 Fe3 plus 5 electron. Add these two equations, add both these half equation in such a way that no electrons left in overall equation. So in the overall equation, there will be no, sorry, in the overall equation, we should not left with any electron. Let's see. So cancel electrons. So these 5 electrons get cancelled from this side, these 5 cancel from that side, and randomly you can add reactant on the reactant side and a product on the product side. So on the reactant side we have MnO4 minus plus 8H plus 5Fe2 plus, that gives Mn2 plus 4H2O plus 5Fe3 plus. Is that okay? Now we have to check is everything balanced or not. How many Mn? 1 Mn, 1 Mn. Okay. How many oxygen atoms? 4 oxygen from here, 4 oxygen from here, 4 oxygen, 4 oxygen. Okay. How many hydrogen? 8 hydrogen. 4 times 2, 8 hydrogen. How many Fe? 5 Fe2, 5 Fe atoms, 5 Fe atoms. Don't worry about the charges. We will balance the charges. Let's see the charges on the left side and the right side. So 8 positive, 5 times 2, 10. 8 plus 10, 18 positive. 18 positive. Take away 1 electron, 1 negative. So 17 positive on the left hand side. Check here. 5 times 3, 15 positive plus 2 positive. 15 plus 2, 17 positive charges. 17 positive charges on the left side, 17 positive charges on the right hand side. So everything is balanced. So that's our final overall equation, meaning MnO4 minus, actually it's KMnO4 minus, but the potassium is the spectator ion. MnO4 minus, which is a well-known oxidizing agent, it oxidizes Fe2 plus to Fe3 plus. Can we do one more example? Write down one more equation. First we will do the half equations. Potassium dichromate Cr2O7 2 minus becomes Cr3 plus. This is not the V, guys. My handwriting. This is R, chromium. Cr3 plus. Okay. You can use ferrous or you can use copper. Copper is a metal. Cu becomes Cu2 plus. Half equation. Both of them are the half equation. I want to start with the first half equation. Potassium dichromate, which is orange in color. When it oxidizes, its color changes to green. Potassium dichromate is also a well-known oxidizing agent. It oxidizes primary alcohol to aldehyde, which further oxidizes to carboxylic acid. I will make videos on the organic chemistry. I didn't start yet. I will make videos on organic chemistry in the future. Anyways, potassium dichromate, Cr2O7, actually it's potassium dichromate. Again, potassium is the spectator ion. Cr2O7 2 minus becomes Cr3 plus, and it oxidizes copper Cu to Cu2 plus. Let's follow all the rules just now I have discussed to balance the half equation by ion electron method. Now, same thing, balance the oxygen by using water molecule, left side and right side. How many water molecule I have to add here? 7 H2O. Balance oxygen atom by adding H2O. Cr2O7, 2 minus, Cr3 plus 7 H2O. Now on the right side I have 14 hydrogen atom. Balance hydrogen atom by adding balance hydrogen atoms by adding H plus ion. We are balancing half equation in the acidic medium, that's why we are using H plus ions. On which side, guys? On the left side, because on the right hand side I have 14 hydrogen excess. So add 14 H plus Cr2O7, 2 minus, becomes Cr3 plus 7 H2O. Is everything balanced? Before balancing the charges, check everything balanced. Chromium 2, chromium 1. Most of the students, they ignore this part. They thought everything is balanced. No, you have to check by inspection. Just check all the atoms are balanced or not before adding electrons. So how many chromium here? 2 chromium. I have to times by 2 here. Now charges. Let's balance the charges. 14 positive and 2 negative. So 12 positive on the left hand side. How many positive on the left hand side? 12 positive. 2 times 3, 6 positive. So 6 positive. So out of 12 on the reactant side, it gives away how many positive? 6. So how many positive charges are they on the left side in excess? 6 positive. How can we balance the positive charges? By using electrons, by adding electrons. So add 6 electrons, add 6 electrons on the left side. Okay, 6 electrons plus 14H plus Cr2O7, 2 minus, becomes Cr3 plus how many chromium? 2 chromium plus 7 water molecule. Now check everything is balanced or not. Why I'm keep on telling check everything is balanced or not? If you can't balance one half equation, if you won't check it, and if you try to balance everything, you will get a wrong answer at the end when you add both the equations. So check every time, you have to check whether this half equation is balanced or not. One more time, guys. Look at that. Chromium, how many chromium? 2 chromium, balance. 2 chromium, 2 chromium, balance. How many oxygen atoms? 7 oxygen atom. 7 oxygen atom, balance. How many hydrogen? 14 hydrogen atom. 14 hydrogen atom. Now charges. 14 positive. Okay. 6 and 2. 8. 14 minus 8. 6 positive charges. Excess here. And 6 positive charges. So both are cancelled on each side. Now, it oxidizes. I told you, potassium dichromate is the well-known oxidizing agent. It oxidizes copper Cu to Cu2 plus. It's taking the electron from the copper. Now, how many copper on each side? 1, 1. You don't need to balance copper. Is there any oxygen? No oxygen. So we don't need to balance oxygen. We don't need to balance hydrogen. Only the charges. Look at the charges. 0 charge and 2 positive charge. How can we neutralize the positive charge? By adding electrons on the right side. Just add 2 electrons. Add 2 electrons here. So this is my equation 1. That's my equation 2. We have to add both the equation in such a way that you have to cancel electron in the overall equation. The overall equation should not contain any electrons. Now, how can I cancel 6 electron and 2 electrons? The easy way is time this equation by 3 and make this 2 electron into 6 electron. So time this by 3. Now look at that. How many copper? 3 copper on that side. 3Cu becomes 3Cu2 plus 6 electron. Check the position of the electron. What do you mean, sir? The electron should not be on the same side. Otherwise, we have to add the electron. The electron should be on the opposite side. Now look at the number of electrons. Here on the left side, here on the right side. Can we cancel? Yes. Cancel, cancel. Add these two equations. Add both the equation randomly, reactant on the reactant sides, product on the product sides. So C14 H plus Cr2O7 2 minus plus 3 copper, that gives Cr3 plus 2 Cr3 plus 7 H2O plus 3 Cu2 plus. Is everything? Let me check. Let me check, is everything balanced or not? Look at that. How many chromium? 2 chromium. 2 chromium, balance. How many oxygen? 7 oxygen atom from this side. 7 oxygen atom from that side. How many hydrogen? 14 hydrogen atom. 7 times 2, 14 hydrogen atom. How many copper from here? 3 copper, 3 copper. Now the charges. 14 positive, take away 2 negative. How many? 12 positive on this side. 12 positive. 2 times 3, 6 positive. 3 times 2, 6 positive. Is everything balanced? 12 positive on the left side, 12 positive on the right side. This equation is completely balanced. So I want to stop my video here. I will come back with this type of question. We will do this balancing the half equation question in acidic media as well as in the basic media in my next video. Please, if you have any question regarding the redox reaction or any kind of question in terms of organic chemistry or physical chemistry, please write down your question in the comment box below and send it to me. Thanks for watching this video. Hi guys, welcome back to my channel. Hope you are doing well. I've already started how to balance the half equation by using ion and electron. Please watch that video. So let's do the continuation of that balancing of half equation. Look at that question. So first check which element get oxidized and which element get reduced. Look at that. Here Pb X, suppose Pb, I don't know, plus oxygen is minus 2 times 2 equals to 0. X minus 4 equals to 0. So X equals to plus 4. So Pb from here goes plus 4 to plus 2. So here plus 4. That becomes plus 2. So increase or decrease, guys. A decrease in the oxidation number, meaning reduce. This get reduced. And look at that, minus 1, Cl minus 1 to become 0. Chlorine here, look at the chlorine. Oxidation state of chlorine in chlorine molecule is 0. So minus 1 to 0. Increase mean oxidation number increase during that chemical reaction, meaning it get oxidized. Oxidized. Now, so these are two half equations, and I have already discussed the rules to balance the half equation by using ion electron method. Let's continue. Like you can You can do oxidized part first or reduced part first, doesn't matter. So PbO2 becomes Pb. I told you first balance oxygen, so that's 1/2. Balance oxygen by using water molecule. How many oxygen extra here? 2 oxygen extra. I want to add a 2H2O. How many hydrogen extra here? 4 hydrogen atom. So add 4H plus. Now the important point is to balance the charges. That's the crux point of the balancing equation. All the charges are balanced by using electron. 4 positive charge, so I have to use 4 electron. Is there any? My bad. Is there any 2 plus? Yeah. So 4 positive gives away 2 positive. So how many positive left on this side, guys? 2 positive charge. So 2 positive charges are balanced by using 2 electron plus 4 hydrogen plus PbO2 gives Pb2 plus 2H2O. Let's check everything is balanced or not. How many lead? One lead, one lead, one Pb, one Pb. How many oxygen? 2 oxygen atom from that side, 2 from that side, 4 hydrogen, 4 hydrogen. Now the charges: 4 positive, take away 2 negative. So 2 positive left here and 2 positive left here. Yeah, it's balanced now. Now the chlorine, Cl minus to become Cl2. First look at the chlorine. Chlorine is not balanced, so I want to times 2 here. 2 means add a 2 electron here to balance that side. 2 negative charges are extra on this side, so take 2 extra, take 2 electron on that side. Now it's balanced. And make sure, guys, when you're adding 2 half equation, the electron should not be on the same side. What does it mean? Here my electrons are on the reactant side, here the electrons are on the product side. How many electron? 2 electron, 2 electron get cancelled, easily get cancelled. Add them up. Reactants on the reactant side and the products on the product side. So 4H plus plus PbO2 plus 2 Cl minus becomes Pb2 plus 2 H2O plus Cl2. Check the reaction is balanced or not. Now how many Pb1 Pb balance? How many oxygen atom? 2 oxygen atom, 2 oxygen atom balance. How many chlorine? 2 chlorine, 2 chlorine balance. How many hydrogen? 4 times hydrogen, 4 hydrogen here. 2 times 2, 4 hydrogen here. Plus 2 plus 4 charge minus 2. So plus 2 left here, plus 2 left here. Now we will do one more equation, balancing of equation. Okay. Try that one, guys. Check the oxidation state of sulfur here and iodine here. First, you have to figure out which element or which compound undergo oxidation and which one undergo reduction. Let's check that. Sulfur 2x plus oxygen minus 2 times 3 equals to minus 2. This time minus 2 is not equals to 0. So 2x minus 6 equals to minus 2. So 2x minus 4 equals to 0. X equals to plus 2. Now here 4x plus minus 2 times 6 equals to minus 2. 4x minus 12 minus 12 minus 12 equals to minus 2. 4x minus 12 minus 10 equals to 0. X equals to 10 over 4, which is more than 2 point something. That's the average oxidation state, and I have already shown whenever we have sulfur-sulfur linkage in that molecule, the sulfur-sulfur bond has zero oxidation state. Anyway, it's 2.5, which is the average oxidation state, of each sulfur atom. When you take the average, because we have 4 sulfur in that, 2 of them has 0, 0, so we have to take actually 2, so which is 5 actually. Yeah, but when you take the average of that one, it's 2.5. Anyway, so oxidation number, I think, increase, meaning sulfur get oxidized. What about here? 0, 0, iodine 0 to become minus 1. 0 to become minus 1, a decrease, so iodine get reduced. So this is oxidized, that reduce. Let's see, balance the equation, this equation and that equation, half equations. Look at that. Sulfur S2O3 2 minus becomes S4O6 2 minus. How many sulfur? 4 sulfur, 2 here. So 4 sulfur here, 4 sulfur here. Now look at the oxygen. 2 times 3, 6, 6 oxygen. Look at the charges. 2 times 2, 4 negative charge. So 4 negative charge and 2 negative there. So 2 negative charge left here. 2 negative out of 4, it gives away 2 negative. So I have to add 2 electron to balance 2 negative charge here. Now I2, we don't need to balance oxygen. Oxygen is already balanced. 2 times 3, 6 oxygen. So one more time, check is that equation balanced or not. 2 times 2, 4 sulfur, 4 sulfur, 2 times 3, 6 oxygen, 6 oxygen. 2 times 2, 4 negative. So 2 negative, 2 negative, 4 negative balance. I2 to becomes 2I minus. Now iodine balance only the electrons. So 2 negative charges extra here. So I want to add a 2 electron here to balance that 2 negative charge. Now everything is balanced. Now add both the equation in such a way that no electron left when you add them up. Now look at that. Cancel these 2 electrons, cancel these 2 electrons, add them up. Reactant should be on the reactant side and product on the product side. So 2S2O3 2 minus, like this is sodium thiosulfate, Na2. Sodium is the spectator ion, and this is tetrathionate. 2S2O3 minus plus I2 iodine become S4O6 2 minus tetrathionate plus 2I minus. Yeah, we will do one more. Look at that one. Sulfuric acid to become SO2, sulfur dioxide gas. Br minus to become Br2. So sulfur, work out the oxidation state of sulfur here. 2 plus x minus 8 equals to 0, x equals to plus 6, uh, x minus 4 equals to 0, so x equals to 4, so plus 4 here, plus 6 to plus 4, what happened? Decrease, so sulfur get reduced. Br minus 1 to become 0, minus 1 from minus 1 to 0, so it increase, it get oxidized and sulfur get reduced. Now balance these two half equation. H2SO4 becomes SO2. How many oxygen on that side? 4 oxygen, and here 2 oxygen. To balance by using 2 water molecule, 2 water molecule. Now check how many hydrogen? 4 hydrogen, 2. I will balance later on. 1 sulfur, 1 sulfur. How many oxygen? 4 here, 2 plus 2. How many hydrogen on that side? 4 hydrogen and 2 here. So add 2H plus. Hydrogens are always balanced by using proton or H plus ion. So I have to add 2 electron here. Add 2 electron because to cancel 2 positive charge, I have to add 2 electron plus 2 H plus plus H2SO4 sulfuric acid, that becomes sulfur dioxide plus water. So look at that. We are balancing all these equations in acidic medium. I will teach you how to balance the equation in alkaline medium or basic medium. Now check everything is balanced or not. 1 sulfur, 1 sulfur, 4 oxygen, 4 oxygen, 4, 2 oxygen, 2 oxygen and 2 oxygen, 4 oxygen. How many hydrogen? 2 times 2, 4 hydrogen, 2 hydrogen, 2 hydrogen balance, 2 positive charge, 2 negative charge, that's also balance. Br minus becomes Br2. How many bromine? 2 bromine after times by 2. So this side we have 2 negative charges, which is extra, so I have to add a 2 electron on that side. Okay, now cancel those electrons, cancel the electrons. When you add them up, you have to cancel these electrons, cancel those electrons, cancel those electrons, and add them up. Add the equation. So reactant on the reactant side, H2SO4 plus 2H plus 2Br minus, that becomes SO2 plus 2H2O plus Br2. Check everything is balanced or not. Br2, 2 hydrogen plus 2 hydrogen, 4 hydrogen, 4 hydrogen balance, 1 sulfur balance, 4 oxygen, 2 balance, 2 bromine, 2 bromine, 2 positive charge and 2 negative charge. This is also balanced equation. Look at that, guys. Chemistry, you can't memorize the chemistry. I challenge it. So you have to learn the concept. Once you learn the concept, chemistry is very easy, guys. Now, can we do one more? Now, look at that. This is very interesting question. We are using iodate ion, and this is iodide ion. This 8 like iodate ion, this is iodide ion. So first, I want to times by 2 here. So IO 3 minus becomes I2 times by 2. How many oxygen? 6 oxygen. Add 6 hydrogen, 6 water molecule. Sorry. How many hydrogen? 12. So add 12 H plus. 12 positive. 2 I2 balance. 2 times 3, 6 hydrogen, 6 hydrogen. 12 sorry, 2 times 3, 6 oxygen atoms. 6 oxygen atoms, 6 times 2, 12 hydrogens, 12 hydrogen. Now 12 positive, take away 2 negative. So 10 positive charges, 10 positive, 10 positive. So those 10 positive charges are balanced by using 10 electron, add a 10 electron, 10 electron plus 12 H plus 2 IO3 iodate ion, DATE, becomes I2 plus 6 H2 water molecule. Now I2, I minus iodide become I2, and we can titrate this with sodium thiosulfate. We can use the starch. Starch turns the iodine into blue black color. So it's a kind of iodine clock. So 2 minus, so 2 iodide, ITE, iodide, IDE, iodate, ATE. So 2 times 2 negative charge, so add a 2 electron here. So 2 iodide, I2 plus 2 electron. Yeah. Now look at that. In that equation we have 2 electron. In that equation we have 10 electron. How can I make 2 into 10 electron? Times by 5. So simple. This equation you have to times by 5. So we have 10 I minus becomes 5I2 plus 10 electron. Cancel those electrons. 10 electron from here, 10 electron from here. Yeah, when you are balancing the equation, guys, be patient, don't rush, and look at each atom. You have to balance each atom and their numbers. Now add them up. I told you reactants on the reactant side, product on the product side. Add them up. So we have 12 H plus plus 2IO3 minus plus 10 iodide. That becomes I2 plus 5I2 plus 6 water molecules. Check the equation is balanced or not. 2 iodine from that side, 2 from this side. 10 I minus 5 times 2, 10. So how many total iodine? 2 plus 10, 12. 2 plus 10, 12. How many oxygen atom? 2 times 3, 6. 6 here. Hydrogen atoms, 12 hydrogen atoms. 6 times 2, 12 hydrogen atom. Look at the charges. 12 positive, 10 negative. How many positive left? 2 positive left. 2 times minus 2. So balance one more time, guys. 2 minus and 10 minus, 12 negative charge, 12 positive charge. So everything is balanced here. It's tricky, very tricky. And I've seen most of the past paper that question came up. So if you have any question of balancing the equation, whether it's an acidic medium or alkaline medium, write down the question and send it to me in my comment box, or any type of chemistry question, please send it to me. I will get back to you. So I want to stop my video here. Thanks for watching my videos. I'm back to my channel. Hope you are doing well. I didn't make my video for a long time because I was very busy. Today I'm going to continue my lesson of a redox reaction. We have already done balancing of half equation by ion electron method. In that, with the examples, we have done so many examples. Let's do this example. I've seen this question in many past paper. Do you want to try it? See, it's easy though. First of all, you have to check which compound undergo oxidation and which compound undergo reduction. So can you try it? Mn, this is MnX, oxygen is -2, so plus -8 equals to -1. So x minus 8 equals to -1, x minus 7 equals to 0, x equals to +7. Now check here. So +7, Mn +7 to become 2 plus. Increase in the oxidation state or decrease? Decrease in the oxidation state, so Mn get reduced. Now 2x, I don't know, carbon plus -8 equals to -2. 2x minus 8 equals to -2. 2x minus 6 equals to 0. X equals to 6/2, which is 3. Now check here. Carbon x minus 4 equals to 0. X equals to 4. So from here to here, oxidation number increases. So carbon in that case get oxidized. Now separate these two equations and balance those two equations separately. So Mn, even you can balance first C2O4 minus. This is dioate ion. This to this doesn't matter. You can balance oxidation reaction first and reduction reaction later on. So Mn, MnO4 minus becomes Mn2 plus. I told you no oxygen here. How to balance the oxygen atom? By adding water molecule, add 4H2O. Now how many hydrogen extra here, excess here? 8, so add 8H plus. Now balance the charges. 8 positive, 1 negative, 7 positive on this side, and it gives away 2 positive on that side. So 5 positive. Positive charges are balanced by using electron. 5 electron, 5e minus plus 8H plus MnO4 minus becomes Mn2 plus 4H2O. Check everything is balanced or not. Mn, 1 Mn balance. 4 oxygen balance. How many hydrogen? 8 hydrogen. 4 times 2, 8 hydrogen balance. Now the charges. 8 positive and 6 negative, meaning 2 positive left here and 2 positive left here. Everything is balanced. Now balance this ethane dioate ion to become carbon dioxide, or this is called oxalate ion. Common name is oxalate ion, that come from oxalic acid. So C2O4 2 minus to become CO2. How many carbon, guys? 2 carbon. So times by 2 here. So carbons are balanced. Carbon atoms are balanced, oxygen atoms are balanced. Well, look at the charges. How many? 2 negative charge. On this side, 2 negative charges are extra. So I'm adding 2 electron on that side. Now, when you add both the equation, the electrons should not be left in overall equation. So how can I cancel these? Electron times this times by 2, so that I will get 10 electron, and this times by 5, so that I will get 10 electron. So the top equation, 10 electron plus 16H plus 2MnO4 minus to become 2Mn2 plus 8 H2O 8 water molecule. From that, 5C2O4 2 minus to become 10 CO2, 10 carbon dioxide. This is CO2 plus 10 electron. Cancel those 10 electron, 10 electron, add them up. Just add them up. Reactants on the reactant side and products on the product side. Now look at that. 16, randomly you can add, but reactant should be on the reactant side. 16H plus 2MnO4 minus plus 5C2O4 2 minus becomes 2Mn2 plus 8H2O plus 10 CO2. Let's check one more time. Is everything balanced or not? 2Mn balance. 2 times 4, 8 oxygen. 8 oxygen from here, balance. How many carbon? 5 times 2, 10 carbon. 10 carbon. 5 times 4, 20 oxygen atom from this side. 20, 10 times 2, 20 oxygen atom from that side. Now the charges. 16 positive charge and 2, that's 16 positive. I have 16 positive charge, 16 positive, 2 negative and 10 negative. So 2 plus 5 times 2, 10. 12 negative. How many charges left? 4 positive left. Now look at that. 2 times 2, 4 positive left. 4 positive left. So everything is balanced. Check, everything is balanced. Look at this example. Very similar to the previous one. So do you want to try it? Look at that one. Here, chromium get reduced and carbon get oxidized. Let's balance the chromium first. Cr2O7 2 minus to become Cr3 plus. How many chromium? 2 times by 2, 7 oxygen, so add 7 water molecule, 14 hydrogen, add a 14 H plus. Now balance the charges. 14 positive, take away 2 negative, 12 positive. Out of 12 positive, the reactant gives away 6 positive on that side. So 12 minus 6, 6, add 6 electron, 6 positive left here. Positive charges are balanced by using electrons. Now C2O4 2 minus, we balanced just now, becomes CO2. How many carbon? 2 carbon, so times by 2 here. How many? 2 negative charge, add 2 electron, 2 electron here. So to cancel these 6 electrons, I have to times by 3 here, times by 3. So 3 C2O4 2 minus becomes 6 CO2 plus 6 electron. Okay, and that 6 electron, I want to rewrite this equation here. 6 electron plus 14 H plus Cr 2O7 2 minus to become Cr3 plus 7 water molecule. Now, the electrons of both the half equations should not be on the same side, guys. If they are on the same side, mean you have done a mistake. So be careful. The electron for one half equation should be on the right hand side, and the electron on the other equation should be on the left hand side, because this is a redox reaction. Gaining electron, reduction; giving away electron, or loss of electron, oxidation. So this is oxidation reaction, this is reduction reaction. Now add them up. Cancel, 6 electron cancel. So reactants on the reactant side and a product on the product side. Randomly you just add them up. C2, 3C2, O4 2 minus, plus 14H plus Cr2 O7 2 minus becomes C2Cr3 plus 6CO2 plus 7H2O. Let's check everything is balanced or not. 3 times to 6 carbon, that's chromium, that's not the carbon. This is chromium, and that's the chromium. 6 carbon balance. 3 times for 12 oxygen, 6 times 2, 12 oxygen. 7 oxygen from that side, 7 oxygen from that side. How many chromium? 2 chromium, 2 chromium. How many hydrogen? 14 hydrogen. 7 times 2, 14 hydrogen. Now the charges. 3 times 2, 6 negative, 2 negative, 2 negative. So 8 negative charge, 8 minus charge, 8 minus here, and 14 positive, 14 H plus 14 positive, 8 minus 14 positive. How many? 6 positive, 8 negative, and 14 positive. 6 positive on that side. 2 times 3, 6 positive on that side. So the total equation is balanced. Look at that. 8 negative, 14, so 6 positive and 6 positive. Everything is balanced. Check. So this equation is perfectly balanced. Look at this question. You know, all these examples we have done, balancing of half equation by electron ion method, we balance in acidic medium. Now we have to balance this equation in basic medium. Only slight change we have to do here at the end of the final equation. I will tell you when we will proceed step by step. I don't want to confuse you. A little change, a little twist here, not a big change. We know this will get reduced and that will get oxidized. How, sir? I minus to become I2. How many I2? 2. 2I. So plus 2 electron. Loss of electron. Oxidation. So definitely this will get reduced. So Mn, let's write the equation. Mn O4 minus to become MnO2. How many oxygen? 4 oxygen, 2 oxygen. Add. Don't get confused with that equation. That's the separate equation. That's why I rubbed it. Add 2 water molecule H2O. How many hydrogen? 4 hydrogen plus hydrogen. How many? 4 hydrogen. Now plus 4 plus 1 minus, so add 3 electron, 3 electron. Okay, now I minus to become I2. How many iodide? 2. How many iodine molecule? 2. So add 2 electron here. Here, one more time, let's check the charges, the balance or not. Mn, 1 Mn, 1 Mn balance. How many oxygen atom? 4 oxygen atom, 2 oxygen atom, and 2 oxygen atom balance. 4 hydrogen atom, 2 times 2, 4 hydrogen atom. Now 1 negative, 4 positive. How many positive charges left? 3 positive charges. So I have added 3 electron on that side. Balance, guys. Now I have, to make the electron equal on both the side, I have to times this by 3 and times that by 2, this equation by 2. So I'm using different color markers so that you can see the separate equations. Look at that one, times by 2, so 6 electron, that is my equation. 6 electron plus 8 H plus 2 MnO4 minus becomes 2 MnO2 plus 4 H2O. Now this equation, look at that one, 6I minus become 3I2 plus 6 electron. Cancel those electrons, add them up. 8H plus 6I minus plus 2 MnO4 minus becomes 2 MnO2 plus 4 H2O plus 3I2. Yes, 8 hydrogen, 8 hydrogen. But we are balancing this equation in the basic medium, so there should not be H plus ions in the overall equation. How can we get rid of this H plus ion, 8H plus ion? Add 8O hydroxide ion on both the sides. That's the trick of balancing this equation. You have to add how many H plus ion extra? 8H plus. To make it into the water molecule, add 8OH on both the side. Add 8 hydroxide ion on both the side. You have to do this at the end of the reaction, at the very end. Now, so 8OH minus plus 8H plus, that become a water molecule. So these two become 8H2O, 8 water molecule, plus 6I minus plus 2 MnO4 minus becomes 2 MnO2 plus 4 H2O plus 3I2 plus 8OH minus. So look at that, 8 water molecule from that side and 4 water molecule from the other side. We can subtract them. 8 minus 4, 4 water molecule left here, so 4H2O here plus 6I minus plus 2 MnO4 minus becomes 2 MnO2 plus, I have already taken off this 4 from the 8, so 4 left out, no water molecule, plus 3I2 plus 8OH. Let's check. I want to rewrite this equation here and let's check everything is balanced or not. So 4H2O, 4H2O, 4H2O plus 6I minus plus 2MnO4 minus, that becomes 2MnO2 plus 3I2 plus 8OH minus. That's the minus charge. Now check everything is balanced or not. 2Mn balance. 2 times 4, 8 oxygen. 2 times 4, total 4 oxygen from that side. 4, 2 times 4 plus 8, 8 from that side. 2 times 2, 4 plus 8. How many oxygen? 12 oxygen atom. 12 oxygen atom. So balance. Oxygen atoms are balanced. Now, how many hydrogen? 8. 4 times 2, 8 hydrogen. 8 hydrogen from that side. 2Mn, 2Mn, 6I minus, 3 times 2, 6 iodide, or 3 iodine molecule. No charges, guys. 6 minus and 2 minus, 8 negative. Look at the here. 8 times this minus charge. So 8 negative. Everything is balanced. Now this also a perfectly balanced equation. Only one thing, when we will come across this type of balancing equation, check whether you have to balance that equation in the acidic condition or in the basic condition. Basic condition, only little change, not a big change. Balance the equation as we did in the acidic medium. At the end, at the final time, means at the end of the overall equation, add same number of OH minus ion with respect to this hydrogen. If you have 4 hydrogen extra on that side, add a 4 hydroxide ion. Then this will become a water molecule, and if you have some water molecule on the product side, subtract them. So, and rewrite the equation. I want to stop here and I will continue maybe this topic, or I want to start a new topic. And if you have any question like how to balance the equation, simple balancing of equation, or balance the equation in the acidic medium or in the alkaline medium, please write that question in the comment box and send it to me. Thank you. See you soon.